This is another sign of the times, an analysis, and a commentary. Fracking methane hydrate. Scientists in Japan and the United States say they are moving closer to tapping a new source of energy, methane hydrate, a crystalline form of natural gas found in Arctic permafrost and at the bottom of oceans. At room temperature, the crystal gives off intense heat, earning it the nickname of fire and ice, and making the estimated 700,000 trillion cubic feet of the substance scattered around the world a potentially major fuel source, containing more energy than all previously discovered oil and gas combined, according to researchers at the U.S. Geological Survey. Commercial production of methane hydrate is expected to take at least a decade, if it comes at all. Different technologies to harvest the gas are being tested, but so far no single approach has been perfected, and it remains prohibitively expensive. But booming energy demand in Asia, which is spurring gigantic projects to liquefy natural gas in Australia, Canada, and Africa, is also giving momentum to efforts to mine the frozen clumps of methane hydrate mixed deep in seafloor sediment. The biggest concern is that the sediment that contains methane hydrate is inherently unstable, meaning a drilling accident could set off a landslide that sends massive amounts of methane, a potent greenhouse gas, bubbling up through the ocean and into the atmosphere. Oil and gas companies establishing deepwater drilling rigs normally look at avoiding methane hydrate clusters, said Richard Charter, senior member of environmental group, the Ocean Foundation, who has long studied methane hydrates. Nevertheless, the government of Japan, where natural gas costs are currently $16 per million British thermal units, 4 times the level in the U.S., has vowed to bring methane hydrate into the mainstream by 2023 after a successful drilling test in March. And the government-sponsored test off of the southern coast of Japan's main island, Honshu, a drilling rig bored nearly 2,000 feet below the seafloor. Special equipment reduced the pressure around the methane hydrate crystals, dissolving them into gas and water, and then pumped about 4.2 million cubic feet of gas to the surface. While not a huge haul, it was enough to convince Japanese researchers that more natural gas could be harvested. If Japan can deliver on its vow to produce natural gas economically from the methane hydrate deposits off its shores, it could experience a natural gas boom that matches the fracking-fueled one underway in North America. If you look at what a dramatic shift the North American gas industry has gone through, could you afford to bet against something similar happening in methane hydrate? Successful development of methane hydrates could throw a wrench into liquefied natural gas megaprojects, such as Australia's $50 billion Gorgon development, led by Chevron Corporation. Experts say it could make me have pause about investing billions of dollars in an LNG export terminal, said Christopher Niddle, an energy economics professor at the Massachusetts Institute of Technology in Cambridge. Not all observers think that the cost can come down enough to make methane hydrate viable, but plenty of countries, particularly in Asia, are planning to try. China plans to host an international conference on methane hydrate in 2014. India is contemplating a push to develop the vast quantities of methane hydrate discovered off its coast in the Indian Ocean in 2006. According to U.S. Geological Survey, a part of the U.S. Department of Interior that conducts scientific research. In the U.S., scientists explored the northern Gulf of Mexico in May to map some of the 6.7 quadrillion cubic feet of methane hydrate clusters believed to be underwater there. The Consortium for Ocean Leadership, a nonprofit group of researchers, is now trying to convince the Department of Energy to lend it a research drilling ship to do more tests. There are a huge amount of people internationally working in this area, said the head of the Gas Hydrates Project at the USGS. A lot of national governments have gotten into the game. The most optimal places to harvest methane hydrate are near where the continental shelf transitions to the deep ocean, areas difficult to access from sea level. Would-be producers also have to be careful when harvesting fragile clusters of methane hydrate to ensure nearby crystals don't prematurely break and send greenhouse gases bubbling to the surface. The cost of developing this new source of energy remains high, with estimates ranging from $30 to $60 per million British thermal units. In the U.S., natural gas currently trades for less than $4 per million BTUs, as the rise of fracking produced a gas glut. But countries like Japan, Korea, India, and Taiwan import gas at a high price and thus may find it economical to produce their own resources, said a professor at Rice University in Houston who has done research on methane hydrates. So, tapping methane hydrate for natural gas might have a positive impact on global energy production, but critics say the potential fuel source could have a negative impact on global warming. The trillions of cubic feet of methane hydrates contained in the ocean's floor are in geologically unstable areas. The fear, one wrong move, and an undersea landslide in the muddy sediment containing the methane hydrates could send massive amounts of a particularly potent greenhouse gas to the ocean's surface and into the atmosphere. Adding more methane to the atmosphere is a really bad idea, said Kurt Davies, research director at Greenpeace, which is known for its use of direct action as well as lobbying and research to sway public opinion on issues including global warming and commercial whaling. Although methane remains in the atmosphere for a shorter time than carbon dioxide, pound for pound, the comparative impact of methane on climate change is over 20 times greater than carbon dioxide over a 100-year period. According to the U.S. Environmental Protection Agency, natural gas is being touted as a bridge fuel to replace oil and coal, while strides are made in wind and solar energy. But backers of switching to renewable resources say successful development of methane hydrate could prolong dependence on carbon-based fuels. Hydrates, when and if they ever turn out to be commercially extractable, will be just one more excuse to fiddle while Rome burns, said Richard Charter, senior researcher at the Ocean Foundation, a conservation group. This, too, is another sign of the end of times as we know them, transition days, which is a time of extraordinary happenings, changes, and events, because it's about what kind of world are we leaving to the future generations. And that should be a very important question to ask. Again, Revelation chapter 8, verse 8. And the second angel sounded, and as it were a great mountain, burning with fire, was cast into the sea, and the third part of the sea became as blood. 9. And the third part of the creatures which were in the sea and had life died, and the third part of the ships were destroyed. 10. And the third angel sounded, and there fell a great star from heaven, burning as it were a lamp, and it fell upon the third part of the rivers, and upon the fountains of waters. 11. And the name of the star is called Wormwood, and the third part of the waters became wormwood, and many humans died of the waters, because they were made bitter. 12. And the fourth angel sounded, and the third part of the sun was smitten, and the third part of the moon, and the third part of the stars, so as the third part of them was darkened, and the day shone not for a third part of it, and the night likewise. 13. And I beheld and heard an angel flying from the midst of heaven, saying with a loud voice, Woe, 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 to the inhabitants of the earth, by reason of the other voices of the trumpet of the three angels, which are yet to sound. It's time for the physical and spiritual manifestation of the book of Revelation. And all these are more signs.